On this episode of Sustainable Horizons,
buildings are responsible for roughly 40% of the energy consumption in the United States alone.
Figure out what is the absolute minimum that you need to use to begin with, and then start investing in the efficient technology.
My parents got solar, and they went carbon neutral. Dude, it was $50,000. It's not a cheap investment. Guess what?
What?
We're back!
Sweet.
This time on a topic I am well versed in. My expertise, per se. Today we're going to talk about insulation. Not a super sexy topic, but I think one that's really underrated in sustainability in general. It's kind of like the place to start when it comes to thinking about sustainability in buildings. That being said, insulation is one of the most practical and cost-effective ways that buildings can be more energy efficient. Whether that's new construction, thinking about how they design their homes and the thickness of their walls and the insulations that they put in there, and retrofitting older buildings as being kind of the bigger piece of the puzzle because the best home is a home that's already built. So how do we make these homes more energy efficient? And oftentimes, insulation is the number one place and the cheapest place to start. Next, you're going to want to go to windows and things like that. But yeah, it's kind of a relatively low-cost solution. You're going to lower your energy bills. You're going to have less carbon dioxide going into the atmosphere from
power plants,
whether that be coal or natural gas plants. So insulation is kind of a simple concept. The goal is to keep the outside out and the inside in. So there's just this barrier between whether it be the hot or the cold outside, especially here in Minnesota, we have extremes on both ends. That's what insulation is kind of helping create, is a perfect climate inside where nothing's changing and your utility things don't have to work as hard.
Yeah, because especially here in Minnesota, we're kind of in a unique area because closer to the equator, they tend to be just hot all the time. And the lowest they get is 60s. And if you're way northern Sweden or, somewhere crazy like that, I don't think anyone has ever described Sweden as crazy, but it's consistently cold where the highest it gets will be 60, 70 degrees. But here in Minnesota, on a given year, we will go from negative 40 up to 100, 104, 105 we've seen. And I was just looking this up. The largest temperature swing we had in one day was 78 degrees. And you may be asking, why is that important? It's because when it comes to home design, you want to design your built environment, your home, your building, your structure to the environment that you're in. So in the South, you'll try to capitalize on shade and breeze as these free ways to keep cold. Whereas in the North, you're trying to capitalize on keeping in all the heat that you possibly can. But being in this middle spot and climate-wise brings more challenges because you can't really be fully geared towards one or the other.
Where insulation kind of bridges that is passive homes or solar homes down in the South are super popular. They have the long overhangs so that there's more shade provided. You still have windows, but there's not sun coming directly into the home to warm it up. You can't do that concept here in Minnesota when it gets hot in the summer because then you're cold all winter when no sun reaches the inside of your home. And vice versa, in the winter, you don't want this, you want winter sun to come in, but you don't want it in the summer. And it's not we have retractable awnings that we want to keep out all summer long.
They'd snap off in the winter too.
It's just not possible through design necessarily to hit both components here in Minnesota. That's where things like insulation come in and can provide that barrier while not having to over design one way or another. So you can kind of design for the middle where you may have a little bit longer overhangs depending on where you're located and how far north you go, but your walls are maybe a little bit thicker and you have more insulation so that when it is really hot, you're still cool inside because you have that barrier, and then vice versa for when it's cold outside. And the sad fact about this amazing concept of just insulating so you don't have to design is 90% of American homes are under insulated. which is a staggering amount.
Well, I mean, I'm not shocked because a lot of these older homes, they were just, even in these colder climates, they were just putting newspaper in the walls.
Yeah. And horsehair. It's wild what you can still pull out of a home today.
Yeah.
And yeah, you're right. It's 5 newspapers stacked up. Like you got maybe an inch of insulation.
Yeah, and
it's
not even well.
Yeah, it's not designed to be insulation.
Yeah, it looks like they just read that morning's paper, crumpled it up, and tossed it in the wall and called it a day.
Yeah, I mean, they were getting there. They kind of started to understand like something needed to be there, but with the technology, 70 years later from a lot of these 1950 homes, we're a lot further along, a lot different place in like how we think about how we need to insulate stuff. Brought some stats from Project Drawdown, one of my favorite little organizations out there.
Gotta love stats.
Yes, they say that if annually we added 1.6 to 2% of existing residential and commercial buildings in temperate and tropical countries installed insulation with a low carbon material, which we'll get into that later, we could avoid 15.38 to 18.54 gigatons of CO2 equivalent between the years 2020 and 2025. So it's hard to comprehend that number, but it's a massive amount of CO2.
Yeah, I did not expect it to be that high.
It's insane how important this piece of the climate change puzzle is, and I think it's so being under-insulated. I think it's under-talked about as well.
And also the cost savings on that have to be crazy.
Over the lifetime of the building, heating and cooling savings could be anywhere between $19 to $22 trillion in that same time frame.
Damn, it's the GDP of some countries.
It's insane. It's almost the GDP of our country. We're at 35 trillion or something like that. No, we're at 35 trillion in debt. I don't know what we are for GDP. But yeah, it's an insane amount. It costs somewhere like 700 billion to implement the amount of insulation needed to kind of hit these same numbers. So your return on investment is insanely high in kind of a short period of time. So I own Cloud9 Insulation, a company here in Minneapolis that has brought a brand new insulation product to the Midwest. We don't make this product. This product comes out of Maine. It's the first U.S.-based wood fiber insulation plant. That's a company called Timber HP, and we met them probably a year before they officially had product come off their line. Met with them, really loved the idea of who they were and what they were trying to do, and we decided, let's start a company here in the Midwest and bring it immediately here, and not wait for their plan to eventually have a plant here in 10 years. Immediate action is better than something 10 years down the line.
So, kind of ignorant question. The only insulation that I can really think of off the top of my head is fiberglass.
Yes.
How does wood insulation compare to fiberglass, both in use and effectiveness?
Wood fiber outperforms fiberglass on almost every front. Where we become more of a competition is with cellulose, which is recycled newspaper and cardboard boxes. They turn that into insulation as well. So it's another kind of eco-friendly option. But wood fiber compared to fiberglass, the fluffy pink stuff most people have in their homes, outperforms on a lot of levels. So fiberglass has roughly 2.4 to 3.0 R value per inch, and wood fiber has a 3.8 R value per inch.
And what is an R value?
Basically, it's like the thermal resistance per inch. And so the higher the thermal resistance, the better the insulation, because the less of it you might need in a specific space. So thinking between your walls, you often have 2x6s or 2x8s in a wall. The higher the R value, the more insulation or the more resistance you have in that smaller cavity. So it outperforms on R value. It outperforms on moisture management. Cellulose does not do well with water. So if you have a leaky roof, which is a whole other problem in of itself, but that happens sometimes, that moisture is not good for that insulation. Wood fiber is hydrophobic, so it can take in water and then release it. It'll absorb it, and then it'll also let it go. It doesn't hang on to it forever, which is a positive on that front. It doesn't settle like fiberglass and cellulose do, so it's going to hold its thermal air pockets, which is basically how insulation works. Is you have air pockets that stop the flow of heat
It's the same way that your Stanley thermos works, is that there's that vacuum seal and that gap of air that prevents the conduction of heat.
Yep, so it just, you have to warm the air and then it has to move on. And so you have a bunch of those pockets in your insulation. So it outperforms on every level of wood fiber. And earlier we talked about how we need to use low carbon materials. Earlier we talked about how we need to use low carbon materials to kind of achieve this massive gigatons worth of CO2 being not released into the atmosphere. And a part of that is fiberglass is made out of petroleum products. And so there's an intensive process to actually turn it into insulation. And that's not good. Wood fiber is actually a carbon negative product. So the amount of CO2 that's sequestered during the growth part of the tree is not ever fully released. So we're always going to be storing carbon, even though it goes through a manufacturing process, gets shipped all the way out here, is put through a machine to put in your house. It arrives carbon negative and kind of creates like a mini carbon sink in your home. So yeah, using low embodied carbon materials for insulation is a super important factor. So another one that's kind of new to the North American market is hemp insulation as well. Same concept as wood fiber. Hemp just grows at a faster rate than obviously trees do. So this is like kind of a product that you can grow in a field and then turn into insulation within 90 days, 100 days, however long your production process might be. But a key factor to the wood fiber insulation is that currently the facility in Maine is using leftover wood chips that come out of a lumber mill.
Cool.
So they're making 2x4s, 2x8s out of these trees. They don't use all of it. They can't. So a lot of wood chips are ended up happening in the process, and Timber HP buys them by the ton and then turns that into insulation. So we're not even cutting down trees.
And that's on circularity.
Yes, exactly. They're just taking a waste product and creating like a new life for it, which is great. There's a lot of positive things about that. We're kind of they're boosting the job market, the lumber industry. They actually converted a paper mill and turned it into their insulation plant in a small little town. So yeah, they did that and they rehired a bunch of the people, the skilled workers there that know how to work with products and machinery like this in this small little town, and brought life back into a milling city just in a different way. Instead of paper, now you're making insulation out of the same products you've worked with for the past 40 years.
Yeah, that's great.
Yeah, a really cool company, a really cool product, and it's now here available in the Midwest, and we've gotten a lot of good traction on it, and specifically from people like the passive house industry. And I want to talk about a little bit about passive houses because they have a different approach to it's building design, essentially. And so what they do, most homes, as we've said, usually are built by a 2x4, 2x6, or 2x6, 2x8. Is kind of usually like the standard frame depth of a wall within an American home. What passive house people and designers do is they actually make 36-inch deep walls, between 24 to 36-inch deep. So you went from 6 to 8 to 24 or 36. So you're 4 times deeper.
That's thick with 3 Qs.
It's really going crazy. Yeah, 4 times deeper. And all of that just filled with insulation, because they understand that having the most efficient home means having the best barrier between the outside and the inside. Because we keep their inside on a perfect year. Your inside of your house would probably be 70 degrees on average all year long.
Yeah.
In the summer, 70 degrees feels great. In the winter, 70 degrees feels great. So we don't want to change our climate inside during the summer or winter, but outside obviously changes all the time. And so having that super thick barrier allows them to have very little energy consumption to heat or cool their homes. And they do that on basically kind of all 4 sides. So they'll insulate the underneath because your ground temperature changes too. And, 3 inches of concrete isn't enough of an insulation barrier to really stop that. So they look at all these different things and they make sure that they're as insulated as possible. They make sure that doors and windows and all that kind of stuff are as top-notch and as airtight as possible too. Because buildings just tend to waste a lot of energy.
They really do.
Yeah, there's a lot of gaps. Buildings are responsible for roughly 40% of the energy consumption in the United States alone.
Dang.
And more than half of that goes towards just heating and cooling a home. So like that, just by insulating, you can reduce that 40% to hopefully 20%. Because if you can have next to nothing for heating and cooling because you're well insulated, then everything starts to go down. And that's a huge chunk of the kind of CO2 emissions puzzle that we have here in the United States. So basically, less energy consumption is the main goal of insulation.
Yeah, because I feel like when it comes to homes or even manufacturing facilities, my brain goes straight to, what are you doing inside your home? Are you turning off your light bulbs? Are you using the most efficient oven or whatever? And yet to think about it like, oh, it could just be the house, the building itself. That's the problem.
And that's why technologies like the Google Nest and smart thermostats, they are helpful in like a technology way, because it's like when you're not home, your home does not need to be at such an extreme to the outside. So in the winter, it'll let it cool down. And then before you come home, it'll start to warm it back up. So it's not just sitting warm all day long when nobody's there to utilize that or need to be in that kind of comfort, and vice versa. In the winter, it'll heat up and then it will be eventually cooled down before you come home. So that's one way to kind of reduce the like energy consumption during the day. But in general, if you just had better insulation, you wouldn't actually need that type of extreme because your home wouldn't fluctuate as much. It's just going to sit there and maintain whatever inside temperature you want it to maintain. And I think that's kind of like a huge thing to think about when it comes to like electrification. It's a huge thing we want to do. And you see a lot of homes getting solar nowadays. It's a lot cheaper. You can kind of offset 100% of your, or at least part of your energy consumption through the panels on your roof and stuff like that. But not a lot of these people think about, maybe I should insulate first so I just don't consume as much.
Yeah.
You could probably save yourself 3 or 4 panels that you don't have to buy if you just, insulated a little bit better and made sure you spent money on that first, which is not even a lot of money to do.
One thing that I like a lot, our former director at MidTap, Laura Babcock, would always say, right size your energy use before you purchase renewables or before you go find the next most efficient engine or whatever. It's okay. Figure out what is the absolute minimum that you need to use to begin with, and then start investing in the efficient technology.
It's just, how can you, consume less? It's the reduce, reuse, recycle.
Yep, exactly.
You gotta also reduce before you can think about a clean energy option. And as more things become electric and we move away from fossil fuels, so thinking about cars and people wanting to plug in at home, if you also now want to plug in at home and you don't have the insulation to keep yourself, energy efficient with your heating and cooling, you just need that many more panels, and then it's resources that we're wasting when really we could just start here.
Yeah.
And then think about the rest going forward.
Well, because also to that point, focusing on those reduction opportunities first are often cheaper and quicker solutions than those next big ultra efficiency green energy purchases are.
Yeah, I mean, my parents got solar and they went carbon neutral.
Oh, wow.
It was $50,000.
Jesus. Yeah.
It's not a cheap investment.
Which, that's fine if you are planning to be there for the next 10, 20, 30 plus years, because you'll get your return on investment within that time. But, if you're younger like you and I are, I'd love to install that on my home. But also, I might want to move within 5 years. I don't know.
Reduction is kind of the whole goal of insulation. And I think it's always important to start there when we're talking about sustainability. In almost all cases, because we just want to reduce our consumption, whether that be plastic consumption, energy consumption, material consumption, all the things that we consume in our consumeristic society. We got to think about reducing first before we think about, it's this fancy new technology that's going to allow me to have a bazillion, straws, plastic straws, and not care.
All comes back to straws.
Yeah, it always does. It really, we built that hill and we are dying on it. That's just how it is. We don't want the straw recycler We just want to use less because or use better, use something different. And insulation is kind of the key for building.
Also, it's not just insulating your walls, insulate your pipes as well. Because a lot of your pipes are carrying really hot stuff or really cold stuff. And we want to keep that energy in that pipe and not if you're trying to AC your house, but your hot water pipe is just flowing freely, gonna have some impacts. Not huge, but it's there. It's a real thing.
Yeah, and some places they have their HVAC system up in their attics. And insulating the hot air that's being created in your attic before it gets to your home, you got to insulate it against the cold air that's sitting outside of the insulation. And so it's important to insulate kind of all the things that go on within your walls so that there's just not energy inefficiencies. Insulation is important because it reduces the amount of energy your home consumes or a building consumes. That's my story. I'm sticking to it.
Period.
Also, check out Cloud9 Insulation if you're interested in any type of insulation updates.
Yeah, so Taylor, I guess with that, as we do with most of our guests, so where can people find you?
It's either Cloud9 Climate or Cloud9 Insulation. Just one word, cloud9insulation.com is our website. Trying to do some good stuff over there, and we're excited to kind of get into our builder architect phase, working with a lot of passive home people and builders that want to use more green, healthy materials and stuff we're trying to provide.
Also, for all you This Old House fans, their stuff is featured on that show. So,
yep, Timber HP is just featured on This Old House. They answer a lot of the really great questions because a lot of them, it's wood fiber insulation. Well, it's just going to catch on fire.
Yeah, it doesn't. We should put the link to that episode.
Yep, we can definitely do that in the description. All right, and that's insulation.
Cool. Deuces.